Hello and welcome to the JuliaHub 6.0 webinar. I'm Jay Jagdish, part of the marketing team here at JuliaHub. In this webinar, Panagiotis will take you through some exciting features in JuliaHub 6.0. A little bit about our speaker. Panagiotis is a software engineer here at JuliaHub. He has an electric and computer engineering degree and works on application development and Pluto integration. He's also contributed to the Pluto JL project. Please enter all your questions in the chat. Panagiotis will answer them as they come when he takes time to pause. Over to you, Panagiotis.
Thank you very much, Jay. Welcome, everyone. Today, we're going to talk about JuliaHub and the new features that sixth release brings. So what is JuliaHub? Since you're here, you probably know, but I will just reiterate that JuliaHub is the one-stop shop for you to share your code-based workflows. So we basically help you solve what we call the two environments problem, mirroring Julia's two languages problem. We help you run code that your colleagues and everyone else can run on the same environment using JuliaHub. So on this webinar, we're going to cover the JuliaHub datasets to make that you can use to make your code cloud-based and make it free from every relative files. We're going to show you the JuliaHub Drive, which is the persistent storage you get when you launch your cloud station on JuliaHub. And we're going to show you how you can use Pluto and you can run notebooks that you can then share with everyone in the world. And then they can run them and get the same results. Okay, so what is this JuliaHub? What can it do? Like, JuliaHub is a platform that can do like a million things. Basically, it's it's like your desktop station, but on the cloud. So you can develop code with Julia ID. You can procure bulk compute, which means that you can simultaneously run up to hundreds of nodes with tons of RAM and CPU according to your needs. You can use our cloud-based data catalog that is based on DataSets.jl that makes your scripts relocatable and free them from your machine's file system. You can run Pluto Notebooks, of course, and you can share a collection of the static exports of those notebooks that everyone can run clicking one or two buttons, as we're going to see. For enterprise users, you can also share code with your team and everyone else. You can register packages. Many of you must be familiar with the registrator and stuff. And of course, we host documentation for all of these packages. We are not going to talk about all of these, just about developing code, about datasets, Pluto notebooks, and how we can share static notebooks with the world. Okay, so today is the 27th of February, and that means that tomorrow is Rare Diseases Day, and I'm going to take that opportunity to make a small case study around rare diseases. So the rare diseases are diseases that affect a limited amount of people, but the thing is that a lot of rare diseases exist, so it turns out that a lot of people actually have some rare disease. We're going to download data from this website. This is the Orphanet project, and it provides epidemiology data. And I'm going to use this export of this knowledge base to serve as a baseline for our analysis. So the question at hand that I'm going to answer using all the JuliaHub features is how many people have rare diseases? And the best estimations put this around to 1 to 20. And we're going to use this data on JuliaHub to see if that number, if we can reproduce that number. Okay. So without much further ado, I'm going to jump onto JuliaHub. This is the screen you get after you log in. As you can see, I have both Julia ID and Pluto around. So the first thing I'm going to talk about is how to get a big, beefy machine on JuliaHub. You can quickly jump on your preferences and go to your machine configuration and make sure to pick something that will be a nice fit for your use case. I always take a lot of memory because Julia likes to use memory to be fast. So I'm selecting 4 CPUs and 32 gigabytes of memory here. This will make our workflows run like water. So afterwards, you go to the applications page and you can find Pluto and Julia ID, and we're going to use both in this webinar. So the first thing I want to do is to convert this file over here that I just downloaded from the external service into some nice CSVs that I can load from my computer, from my Pluto instance. So I'm going to open the Julia ID. You can see that launching an application here has become a single click. So clicking any of these buttons will get you the respective applications. I'm using Julia ID in this case. And nope. Okay, so this is Julia ID. Many of you will be familiar with the structure of this. I'm just going to make a new file. I'm going to call it cleanup.jl. Okay, so the first thing we do when we start working on JuliaHub, let's actually explore a bit things around the environment. Okay, so there are 2 very important extensions in this environment. One is Julia, and the other is JuliaHub. So the JuliaHub extension, we're not going to extensively talk about this, but it's quite important to know that it provides you access to see what jobs you're already running, what datasets exist, and some of the datasets features we're going to see and show later in this webinar. And you can also run some files, some of these files on extra compute. You can, with a click of a button, procure from JuliaHub. So if I create a script and I want to run it on 50 nodes, you can do it from here really easily. Stay tuned for another webinar that will cover this. So I'm getting back into the explorer of the files. And very quickly, I'm going to activate this environment. And I'm going to add some packages that I'm going to use in my analysis. So I'm going to add CSV, data frames, XML, JuliaHub client, JuliaHub data, and datasets. Now, a quick look. These 2 are for managing data frames. XML is an XML reader. JuliaHub client is a client that we in JuliaHub use to interact with JuliaHub. This will make our scripts reproducible, and we'll take a data frame and put it on JuliaHub so everyone can use it. And JuliaHub data and datasets coexist to provide datasets inside your code. So I'm going to load this really quickly. I'm going to take a tab and steal it from your view. And let's start writing some code. So using data frames, using easy XML, using dates. And as you can see, Julia starts accepting my commands and everything works as expected. Okay, so the first thing I need to do is I need to upload this file I downloaded from the epidemiology data onto JuliaHub. Now, there are two ways to do this. The easiest one is just drag it from here into the Explorer. So this is uploading the file slowly, and now our file is on the cloud. So I'm going to delete this, make some more space. Okay, as you can see, this is an XML file, and part of the task we're going to do in the first of the two parts of this demo, we are going to transform this file into a usable data set. And then we're going to use the datasets feature to see it and share it with the world. Okay, so let's add some helper functions that we are going to help us work with this file. And let's quickly read the n into a string. That is a big string, it works. And now we're going to use the parse XML function of the easy XML in order to put this into an XML. And having done that, then we pass this through the root function. The root function also resides in the easy XML package, and reading this gives us a node. Okay. So the node we just got is this one, JDBOR. Now, this has some nice metadata, but it's not what we need. We need to go further deep inside and get this disordered list. So we're going to take each element of this doc and collect it into a list and splatter the list like that. And of course, doc is not defined because we need to assign it. Okay, now we have a name and we have two element nodes. You can always see the contents of a node, passing it through the function node content. Of course, that is not useful at all, but it can help you understand that you are on the right path, right? So this looks a lot like this, like it's a new line, this number, and it goes on. So this is what we want. I'm going to make this a bit smaller, just so we have some more space. Okay. Now, we have uploaded this file and we have some really basic script that reads it on Julia. And we have a running Julia session that has this file. Now, where is this file? Where does it live on the JuliaHub ecosystem? So, as we said just a few minutes before, on JuliaHub you can get a big machine, right? And when you ask for a big machine and run JuliaHub ID on it, we attach a very special drive, a very special persistent drive. And that persistent drive you can browse going to compute and then files. So I just went to compute and then clicked on files. And this is a mount that stays on always. Like this is JuliaHub's drive that is reserved just for you. So when you interact with your Julia ID session, this one, the files you see on the on the Explorer on the left are saved in that persistent storage. So as you can see, we have opened the code folder. You can see that here. So if I go to the code folder, I can see that right now, this is the time, the local time in Greece where I am. This is the file I just uploaded. So I can browse it from this user interface too. Okay, so getting back to our task at hand. Okay, so we are going to make two lists. One is going to have the disordered data, and the other one is going to have the prevalence data. And why do I take two lists here? That's because we have a disordered list here on our XML file with 6,000 counts. And this file has entries for its disorder. And every entry has a name, like this one, a type of the disorder, a disease, a group, and then we have the main information that we're going to use, which is the prevalence. Prevalence is the ratio of people that are affected with a disease in a very specific population. So in this prevalence list, we expect to find where that prevalence applies and what kind of prevalence that is. In this case, it's families, and the number is 4. And in the other case, it's point prevalence, and the number is less than 1 in a million. And the geography of the prevalence that needs to be defined is defined as worldwide here. So we have a disease list. Inside the disease list, we have disorders. Each disorder has some attributes and a list of prevalence entries, and we want to extract the information about prevalence. Remember that the question we want to answer is how many people have any of these rare diseases. And the way we're going to answer it is not that scientific, it's more like for demonstration purposes. But it would be exciting if you could like extend this and make an example that is more scientifically correct. Let me also just quickly note that to do this, I took inspiration to do this from this small Nature article, which of course is much more sophisticated than whatever I can do in a 1 hour webinar. But basically, this is one paper from September 16, 2019, that uses the OrphaNet database, the one we just downloaded, and estimates the number of people, the percentage of people that have any rare diseases. And they say it's between 3.5 to 5.9. So this will also be available to anyone who wants to read it and extend on it. But for now, let's get back to our task at hand and see how JuliaHub can help us create reproducible analysis that we can share both with our colleagues and anyone on the internet, basically. Okay, so I'm going to type a for loop for one document in each element of disorder doc, because remember that we go to the second element in that list. So for each of these elements, we are going to parse some information. So I'm using the find first function on the doc. The doc is each node of the disorders doc, so it's a disease in the XML document. And I'm using XPath functions to get all of these and basically put them in an array. So I'm going to push into disorders data, and I'm going to make a name tuple, name D type, D group. Okay, so I'm going to run this and let's see the disordered data again. I'm missing an S. Okay. Okay, so now we have a very nice list that has one name for each disease. And the nice thing is that we can pass this to a data frame, and that will make it even nicer. If I just had a little bit of, yeah, real estate. Okay, so this is going to be one really nice CSV. As you can see, this does not include information about the prevalences. So in order to parse the prevalences, I also need to go inside this document. And let me open the XML again. So we parsed the disorder, but we kept out the prevalence list. So what I'm going to quickly do is for prevalence in find all prevalence list prevalence of the doc, do something. Okay. And the do something is going to be a little bit of magic. I just moved a magic wand. So I'm getting each one of these fields from prevalences, and I'm also I'm pushing this into the prevalence data list, and I'm also keeping the code, which is the ID from the XML file. So let's reset our lists and let's run this for loop again. Okay. This is the first time it runs without failing. I'm very happy for that. So disordered data is this we saw before, and prevalence data includes the entry for the prevalence. And note that you can link these two data lists with the code. Okay, so we have a basic parsing of the XML file we just found for rare diseases. Now, this is no different than doing this in your own laptop. So how are we going to add value using JuliaHub? The answer is we're going to use datasets in order to store that information securely in an immutable object that is versioned and everyone can access it from anywhere. So this is the transition from local to JuliaHub Cloud. Okay. So I'm going to make a temporary file for each of these. One second. So I'm going to make two temporary files, and I'm going to select a name for the dataset that will exist on JuliaHub. This is going to be the disordered data, and this is going to be the prevalence data. So the first step in creating a JuliaHub dataset from our development environment is to write it on a temporary CSV. Of course, you need to use the CSV. You need to be using the CSV in order to use it. Perfect. And now we're going to upload this data set on JuliaHub. So we're going to use JuliaHub client for that. Perfect. So JuliaHub client has a function called upload new dataset, which takes a disordered dataset name, a temporary file, and then gets a list of tags and some description. So I'm going to run this function, JuliaHub client.upload new dataset, with a disordered dataset name. Yeah, 1 second. And it's evaluating, it's pre-compiling stuff. As you all know, Julia loves to do that. Julia loves to do that. Okay, and as you can see, it gives us out information about the transfer. The transfer succeeded. So we got a new data set with a size and some commit messages. And you can also see that this is the first version of the data set, which means that we can update both the data set and its metadata. But we can always access the initial one. So when you run jobs and you have the requirement of them being reproducible, which is a very strict and very important requirement, you can feel safe that with JuliaHub you can always do that. If you have a workflow that uses a Julia file that uses datasets only and no local stuff, then you can always come back to it and get the same results. And this is super important, especially for industries that require reproducibility. For example, anyone who works for, with the FDA, for example. So let's go. So let's take a step back again and go back to JuliaHub. Okay. A few minutes ago, we saw how the files contain the local files we are also seeing. Now we can also take a look at the datasets that live here. And we can see that the datasets we uploaded can also be viewed here. So a new feature we added in JuliaHub 6 is that you can now see these datasets from this UI. So the list of prevalences we just uploaded is available for everyone on JuliaHub to see. And if I'm not mistaken, let me just check the visibility of that. Okay. I just turned it into public. So if any of you is curious and is following through, you can actually see it now. If you go to juliahub.com/UI/datasets and click display public datasets, you can find my name. It's Panagiotis Georgakopoulos 2. And you can find the disorders data I just uploaded. Okay. I also added some tags. It's always very important to tag whatever datasets you upload. That way you can give yourself, your future self, some heads up. And for example, you can remember that you downloaded this from Orphanet. It's an export. It was updated. Then it's a CSV and it's intermediate data. And you can add more metadata in description or wherever. So we give you the primitives to actually tag your work and save time the next time you're going to see any of this. Now, since I just said that, I think it's important to note that most of the savings you get from all this process are not the first time you do anything. So the first time, it's always faster to do it on your computer, minus the 32 cores, right? The 32 gigabytes and the really beefy machines and everything, and the parallelism you can have on JuliaHub. The first time it may look like your computer and your workflow is faster, but the second time, or that day that you want to go to a Greek island and you don't want to be called, like, hey, how did you run this job you don't remember, you don't have your laptop, oh my God. If everything is on JuliaHub, then you don't need to get this phone call, okay? And that's really important. That's like, you can sleep well at night and in your vacation. So I'm going to make this a little bit more sophisticated and also update the prevalence data, because we only updated the disorder data before my trip to Greece. So what I do now is I check if the dataset exists, and if it exists, I upload a new version and I just update the metadata. And I do the same thing for the prevalence dataset. So let's run this and make sure that, yep, that's a new version. And let's remove the temporary files from the local. So let's actually refresh this page and take a look and see that we have now two versions of the dataset. You can see here that this is now on version 2. And if you open up that list, you can see that we have two versions uploaded 5 minutes apart. This was the one I uploaded before, and this one is the one uploaded just now. You can download this, and you can also reference this from your computer, from your script. And that is what will make your research and your analysis reproducible. And I cannot stress enough how important that is. But I'm sure since you're here, you already know. Okay. So basically, I don't have much more to do on this side of things. We now have everything we need to leave our development environment and go to our presentation environment. And before I continue, I would like to ask you if there are any questions, anything you would like to ask me or Jay about JuliaHub or anything I've shown. Okay, if we have any question, you can just type it in the chat. And without further ado, I'm going to continue for the second part, which is going to be the analysis of this data using a Pluto notebook. So you can use Pluto from JuliaHub, as you probably already know. We have the concept of folders. So this is a test folder, for example. I can create one. I got into that screen going to compute and then Pluto. And the nice thing here is that every folder has its own visibility, being private or public. So the new folder I just created is private, but this rare diseases notebook that we're going to write together, we're going to author together, is public. And what this public means is that there is this small HTML link, and this small HTML link takes us to a preview of that notebook. Okay, and since this is JuliaHub.com, you can share this with anyone. Like, I can open an incognito window and go. Okay, so let me just paste it in the chat for everyone who might want to take a look. Everyone can actually come here and check this out. Okay, so clicking this button, I'm taking a small risk. Clicking this button, yeah, will activate this notebook in an editing environment. And note that there is a small issue going on with authentication. You might want to launch a Pluto instance and connect to that first. But other than that, you can see that I just clicked launch and I got a running version of my Pluto notebook. Okay, so I promised you that we're going to check out the rare disease day analysis. We're going to see if we can calculate this 5%, and we're going to do this using JuliaHub and JuliaHub DataSets. Okay, so let me pull the libraries we're going to use here. So we're going to use DataSets and JuliaHub data. This is in order to teach Pluto how to take datasets from JuliaHub. And then we're going to use CSV and data frames. This is to use all the data frames functionality in Julia. And I'm also going to use chain.jl, which is a very helpful library to do some nice data pipelines in Julia. It's more of a style. So let's make some cells and have some breathing space around the code. So let's create a new data frame. So we are going to open the data set. So what I'm doing here is I'm opening the data set that has the name of Panagiotis Georgopoulos 2/disordered data. Let's check. Let's give us some more time. So let's check that this is actually how this dataset is called. So disordered data, yes, that's the one. I'm pasting it here. I'm removing the gaps, and that should work. And open also needs a function. So we're going to use the do syntax. And what that gives us is it gives us a reference to an IO object, which you may be familiar with in Julia, that is a stream of binary data. And we're going to use the CSV package to read that data frame, that IO, into a data frame. So let's see this. And while this is loading, let me just stress out how, like, the awesomeness of referring to data by name, right? This does not need to be on your computer or your instance. JuliaHub and DataSets.jl are smart enough to figure out that this exists somewhere on JuliaHub and bring it down. In the backend, that uses S3, so it's really fast and really convenient and really safe. So you can be sure that your data are safe and will not get lost. And look at the convenience of this. Like, you just referred to a data set by name. I don't know, I find this exciting. Okay, so this is the time where I'm cheating. So I will also use this data set called sample population that I did not show you where I got this. The reason why I did not show you is because I manually curated this dataset in preparation of my webinar. So if you think about it, we have percentages of people in each geography that have a disease, and we also have the geography in which they have the disease. So the missing piece is the population of that area, right? Having the population of that area can help us multiply these numbers, add, and get a total number of people that have the disease. So I'm going to use this data set. I'm going to do exactly the same thing. This is going to be called data frame population. I'm going to open the data set, paste, remove spaces, do IO and csv.read IO dataset, data frame, I'm sorry. Okay, and this is going to warn me that some data do not have columns. Like that's true, like I cheated earlier when I manually was updating some of the data. I'm pretty sure you have done this. Another thing I'm going to do, since we don't have data everywhere, I'm going to use the select function to only pick country and population out of this data frame. So I'm going to make this a bit thinner to only have the information we're going to actually use. Now, the final ingredient for the soup is going to be the prevalence data we made before, which are the most important, if you ask me. So I'm going to copy this. This is going to be the prevalence data, do IO end, and we want to csv.read IO into a data frame. Let's see if that works. It works like a charm. So I'm going to give this a small name. And I'm going to actually join this raw data with the DF population. And I'm going to join on geography to country. Of course, this needs to be a symbol. And the left is a join. Okay, let's see this again. And it didn't work. Okay, it was about time for something to fail. Yeah, okay, so data frames dot left join. Oh, yeah, this is a keyword argument. I don't need to quantify this. This is a keyword argument, yes. Okay, so I just joined the population from the other data frame to the geography using the country. Another thing we need, and the final thing we need, so you can see this P class data point. This is a bit rough as data. It has some weird strings. This, if we see the unique list of these, it's actually nothing, 1 in a million, unknown, 1 to 9, blah, blah, blah. So let's make a really quick, let's map these into probabilities. So nothing will be 0, less than 1 in a million, let's say that it's half in a million, unknown is 0, 1 to 9 in a million is 5 in a million, and so on and so forth. And let's create a new clean prevalence dataset that is going to be chain the DF we just made. Okay, I'm going to start with just the DF. Didn't work. Select all. And I'm going to build from the ground up. Okay, so what do we want to do? We want to left join. Actually, give me 1 second to make this. So I'm making this dictionary into a data frame so I can join. So the first thing I want to do is I want to join this DF with PS on P class to Okay. Let's see if that will work. And as you can see, I got a probability at the end of every one of these. Right. Now, as you can see, some of these are validated. Some of these are not validated. I only want the validated ones. I'm going to use the subset function to get validation by row equal validated. Some got away. And now I'm going to transform this. So basically, I have a population, I have a probability. I'm going to multiply this in a simple way. So transform p pop by row ab a times p. If you know a better way to do this, you can write it in the chat. I've seen that you are very silent. This is going to be people affected. And I did something wrong with the parentheses. Perfect. Okay, so at the end of this, we have a people affected column. So for every point prevalence, we have a people affected. That's great. So let me make another chain. So chain. So I'm going to start from the disease again. Df this, begin and left join clean prevalence on code. Okay, let's drop missing. Much better. Now let's group by code because we don't want multiple prevalences. As you remember, we had a list for every prevalence. We only want one per disease. So we only are going to keep one. So group by code. And then we're going to combine P. Let's try maximum. Okay, so now we have the maximum number of people for every you know, I'm a bit stuck, but you got what we have. We have the maximum percentage of people, the maximum ratio for every disease. And now we're going to take P again. The maximum P is one for every disease, and we're going to sum it. And this is basically 8%. So let's call this Y, and Y of 1 times 100 . Okay, so we just got 8%. So why didn't we reproduce exactly the 5.9% we have here? That is because these people apply some advanced filtering and some sophisticated way to process this, which we didn't do because we didn't have time, but you can do it because, as we said, all the inputs to this dataset, to this notebook, which you can find clicking the link I send you on the web, And you can see that it's updated with the latest analysis because it's being saved every time you change something. So since it uses the JuliaHub 6.0 features and reads the datasets from JuliaHub and does not have anything randomized or anything that may be or may not be there tomorrow, this is an analysis you can take and move everywhere and just reproduce. So to recap, we explored JuliaHub. We saw how you can set your preferences to get more, to get nice specs and do your work without any hassle. We saw how you can open JuliaID, Pluto, how you can connect to JuliaID and upload datasets, files, and then how you can see your files in the datasets if it's something to be shared, or in the files if it's something more private. And finally, we saw how you can use Pluto, how you can use the Pluto files, the Pluto folders, and how you can share static exports of your notebooks with everyone. And since I see that there are still some of you left here, I'm open for questions. Does anyone want to ask something? I will take that as a no, and I guess I just explained everything so good that you don't need to learn anything more. Okay, thank you very much for being around. Jay, do we have anything?
No, I don't see any questions, but thank you, Panagiotis. That was very useful, and yes, you explained it really well. Thanks to everyone who joined us today. We will be sending up a follow-up email that will include a link to the recording that you can view later. And of course, you can always reach out to us if you have any additional questions about JuliaHub. Thank you and have a great rest of the day. Bye.
Bye.